We considered a model with a dummy variable and observe how it affects the intercept for different groups while keeping the slope the same across groups. Specifically, we examined a model where income was regressed on the dummy variable male and the continuous variable education. For each individual I, income is their annual income in dollars. Male is equal to 1 if the person is male and 0 otherwise. Education is their number of years of education, and epsilon is the error. In this model, the effect of gender doesn't depend on the years of education, and vice versa. This may not be realistic. For instance, you might expect that the effect of an additional year of education differs between males and females. Consequently, being male not only influences your average income but also affects how much your income increases with education. Ideally, you'd want the partial effect of one explanatory variable to vary depending on the level of another explanatory variable. To account for this, we add an interaction between the dummy variable and the continuous variable. An interaction term is created by multiplying two regressors together. To see how the interaction term accommodates different slopes for different groups, we can express the expected income for each gender. For females, the male variable is equal to 0. As a result, both the male variable and the interaction term cancel out, and the equation reduces to this. The intercept is beta 0 and the slope is beta 2. For males, the male variable is equal to 1, and the equation reduces to this. The intercept is beta 0 plus beta 1. Beta 1 represents the difference in the intercept between males and females. The slope is beta 2 plus beta 3. Beta 3 represents the difference in the slope between males and females. By using an interaction term, you can effectively estimate separate regressions for males and females. This line represents the regression for females. What would the line look like for males? If beta 1 is positive, the intercept for males is higher than that for females. If beta 3 is also positive, the slope for males is steeper than that for females. This is the worst-case scenario for women. At low levels of education, men earn more than women. As education increases, the rate of return on education is also greater for men than for women. Consequently, the income gap between males and females widens with education. If beta 3 is negative, the slope for males is flatter than that for females. This suggests that even if women start with lower incomes, as they acquire more education, the return on education is greater for them compared to males. Initially, at lower education levels, men may earn more due to advantages in labor-intensive work. However, as the educational level rises, there tends to be a shift towards jobs that require professional skills, which could favor women. When you have an interaction term, it's often useful to consider which line dominates the other and where they intersect. Let's examine how to interpret each parameter of the regression. Beta 0 is the expected income when the person is female and has no education. When a person is female, male is equal to 0. When a person has no education, education is also equal to 0. As a result, the terms involving beta 1, beta 2, and beta 3 drop out, leaving only beta 0. However, beta 0 may not be very meaningful because it's unclear what it truly represents to have no education. Nevertheless, that's what the math tells us. Beta 1 is the difference in expected income between males and females when the person has no education. When a person is male, male is equal to 1. When a person has no education, education is equal to 0. As a result, the terms involving beta 2 and beta 3 drop out, leaving beta 0 plus beta 1. As noted earlier, beta 0 is the expected income when a person is female and has no education. Thus, Beta 1 is the difference in expected income between males and females when both have no education. Beta 2 is the effect of education on income when the person is female. When a person is female, male is equal to 0, so the terms involving beta 1 and beta 3 drop out, leaving beta 0 plus beta 2 multiplied by education. As noted earlier, beta 0 is the expected income when a person is female and has no education. Thus, beta 2 is the difference in income associated with each additional year of education when the person is female. Beta 3 is the difference in the effect of education on income between males and females. When a person is male, male is equal to 1. This results in an intercept of beta 0 plus beta 1, and a slope of beta 2 plus beta 3. As noted earlier, beta 2 is the return on education when a person is female. Thus, beta 3 is the difference in the effect of education when the person is male, compared to females. As you can see, the effect of education on income depends on the level of education. How do we find the marginal effect of being male when the male dummy variable is included in an interaction term? As with any other regression, we use the partial derivative to calculate the total effect of male, taking into account both its direct effect and the effect of the interaction term. The effect of being male is not a fixed number, it depends on the level of education. You can calculate this effect at different points, such as the mean, median, quartiles, or specific levels of education. For example, to determine the effect of being male with 10 years of education, you'd set education to 10 in the derivative. To determine the effect of being male with 15 years of education, you'd set education to 15 in the derivative. The answer will differ at each level of education. The size of the income gap between males and females depends on the level of education, which makes sense. The effect of being male may be smaller at lower levels of education compared to higher levels. Similarly, to obtain the marginal effect of education when it is included in an interaction term, we use the partial derivative to calculate the total effect of education, taking into account both its direct effect and the effect of the interaction term. The formula shows that the slope on education, beta 2, is adjusted by beta 3 if the individual is male. The interaction term causes the effect of a regressor to vary depending on the value of another regressor with which it interacts. The interpretations of beta 1 and beta 2 would differ significantly without the interaction term. Therefore, when including an interaction term, it's crucial to consider its effect to accurately determine the overall marginal effect. For more lessons on econometrics, visit alphas&betas.org.